So the last thing I want to show you is similar to what we would do in school. So we would actually look at some different citrus fruits and see which one made the best battery. So it's going to be a better battery, or it's going to be a more powerful battery if it has a higher potential difference. So we measure potential difference in volts, and we can measure it with a voltmeter. So when I went into school the other day and I brought some equipment out, I have brought the wrong one. I've brought an ammeter. So the ones that we use in school look like this. This orange box, you would connect this in. This should have a V on it because it's measuring the potential difference, which is measured in volts. So Dr. Moore is an idiot and has brought the wrong one, but never fear, because I have one at home that we use when we're testing things and we're building things at home. So this is a similar thing. It is going to give me a reading in volts. It's a little bit more complicated. It can measure both current and voltage. So you just turn it round so it's onto voltage, okay, which is what I've done. So it's going to measure the potential difference for me. So I've got my little lemon set up here. So I don't know if you can see the colours of the metal very well, but I've got the copper and then the zinc electrode, and then I've got a zinc and a copper. So in order to get a measurement of the potential difference, I'm going to have to just complete the circuit. So it's a little bit fiddly, so I'm just going to touch one end of my multimeter to there, and then I'm going to touch the other, and you can see that it's actually registering about 1.5, sorry, I lost it there, 1.5 volts coming from a lemon. So that's actually the same as on one of the batteries that I had earlier. Okay, so I want to test a lime. I think from looking at my clock before, I don't think the orange was very good. So my prediction is going to be that the orange is going to have the lowest potential difference. So I'm just going to put this into my lime. Can't pick it up. I'm going to put this into my lime, and we're going to see, sorry, you can't see it very well, but you can see the screen. So I'm just going to do the same thing. Okay, so, and then I need to complete the circuit and I'll get a reading. Oh, moving a little bit. So I'm trying to keep it still. Fluctuating quite a bit. 1.6, I think there's a little tiny, it's moving. If I try and keep it steady, sorry, I don't want to touch it because that will affect it. Okay, so it's not very steady, seems to be going down. And then last off, let's try the orange. I'm trying to do this quickly because I don't want you to watch a very, very long video, but obviously you'd need to wipe the electrodes because that might affect your results. Okay, so I've got my orange. I think this is going to be quite a bit lower. Okay, so let's see. I'm going to touch it too. So I think it is quite a bit lower once it's sort of balanced out. 1.5. Okay, so I think I would have to do that again to make it a bit more scientific, but I think the lemon and the lime were quite similar, and that the orange was quite a little bit lower, so there was less of a potential difference. So less of a reading on my voltmeter for the orange compared to the lemon and the lime. So if I want to make a little clock or a battery, I'm probably going to use a lemon or a lime and not an orange.